a very positive note on the work that has been presented by the Commander Kuhner and by myself. We're just going to go over the theme we saw yesterday, the theme I approached yesterday. First of all, regarding economic sustainability of the maritime transport business, just out of curiosity, the BDI has increased yesterday, today also. It's around 900 points currently. Just for us to remember that we saw these three main indexes that identify the way the business is, the freight business is growing. One of the four businesses that are the fundamentals of the maritime transport business. The quotation of the BDI and the two other indexes that we saw for tanks that are the barometer of the way the business is growing currently. Yesterday someone asked me here what was the purpose of these barometers, especially the BDI. Besides the immediate application that maritime transport has, there's also a very great application in terms of decision support for the purchase and sale of goods and raw materials. So the BPI also gives us an idea of the tendency, the past and future tendency that the business is having in terms of demand and importation of raw materials. Yesterday I was missing some specificities regarding the index. There's four types of ships, if you remember, the Handysize, the Capesize, the Panamax, but there's also a mix according to the several routes, the Asia Pacific, South Africa, Europe, Asia. So it's a mix because the value of the freight doesn't only have to do with one type of ship, but with several routes in which the ships are actually working. Besides these four indexes that sustained our evaluation in terms of the economic sustainability of the business, we also saw some indexes of shareholder performance of the companies that are working in these markets, especially in the bulk market. We are missing an index to evaluate the transport business. A bit ahead, we identified some of the characteristics of the market. The container ship transportation of cargo that we distinguished from the bulk ship transport. The fact that it is concentrated in great companies and with a great fame and notoriety. And the fact that we were dealing with a tendency in which the dimension of the ship is currently growing. I'm here trying to meet what Christina asked yesterday, to know that if this growth would bring vulnerabilities. The problem has been identified, first of all, in the middle of a peak in terms of fuel prices in 2007 that lasted until 2010. And the problems identified by the industry, or by the most visionary part of the industry, is that the price of this fuel could represent some constraints to the business, to the maritime transport business. Some of you remember, probably as it's my case, or you researched it as well, the shock, the the oil shock of the 70s had as a result an increase in the number of orders and demand of great ships. What we wanted with these big ships was to go around, well, first of all, having some scales economy, but also go around, in a way, some geopolitical tensions that made the navigation in the Suez Canal a bit difficult. With these new units that great operators have been ordering, allows them to transit through navigation canals that make the journeys shorter and more economical. Right now, the Suez Canal can receive the greatest container ships that were built, and simultaneously give them some scale, some dimension that makes this maritime transport good, even if these canals have to increase in the number of miles, for example. They have this sensibilities regarding geopolitical tensions. They've been identified in 2009, 2010, approximately, in a meeting of several entities regarding maritime transport, that are the initiatives for sustainable maritime transport. And one of the constraints that was identified was this one, this possibility of perturbation, geopolitical perturbation, while changing the routes, and also the increase in fuel costs. And so we had to increase the scales economy to balance the situation. We spoke about the shipping business, the brokers. The broker has a very important role in all these businesses, in the freight, in the purchase and sale of new or used ships, or also in recycling, in shipbreaking. We saw which were the main drivers, which factors could increase the sustainability of the four businesses that are part of the freight market, the market of new constructions, and the market of used ships. And we saw that this was an industry that had a great need of continuous financial flow, because it was an intensive capital. And one of the ways to go around some financial stranglement is what we call the FFA, that is a derivative of the freight market that allows to limit the risks that might occur in the future. Then we started on the environmental regulation part. And here, as you know, the IMO is an organization of the United Nations that is dedicated to maritime transport, that accentuates, that gives more importance to not all the nations in the world, because as you know, there are some who do not make part of it, or not a lot, which are our dear Swiss friends. Not being part of the United Nations, they obviously are not part of the IMO. But besides the countries, there's a series of associations and entities of technical character, of professional character, that are also part of this IMO, either with a full right participant status or with an observer status. In some cases, also as observer in some and as participant in others. For example, in most technical areas, one of the organizations that is part of this IMO is the International Association of Bar Pilots, that has had a very important role in the technical area, where it works. It's one of the areas where it participates most, and it also has other opinions in other forums in terms of what is produced in terms of maritime transport regulation. We started talking about the Torrey Canyon accident, all the implications that it had later on. We spoke about this great convention to make maritime transport, especially in liquefied material, NOSIF matters, much more sustainable. We spoke about the increase and the diminution of fields that we've known during the last 30 years. If I have slides, maybe we can put them where we may observe this evolution. We saw that this accident also had other implications in terms of regulation that were environmental and others. And we started talking about the MARPOL Convention, also called MARPOL 7378. Why 7378? The convention was adopted by the IMO in 73 as a result of the Torrey Canyon accident. After 73, 74, 75, 76, 77, it still wasn't in vigor. It still wasn't enforced, and as you know, to be enforced, it needs some rectifications from some countries, and it didn't have them. It had to have the tonnage of these countries, that is a significant number for this convention to enter in force. And so the 78 protocol arrived. This protocol was a subtle way, organized and a politically correct way to do what we've been hearing about lately, and that is the kick can down the road. Basically, throw the can a bit further to kick it, and the problems were still there, but little by little the convention was entering in force, especially in the second attachment. In the first annex, there was some mitigated points, but in the second one, there was not a lot of consensus, and so to make it enter in force was a more gradual process. We already saw this slide yesterday with the main environmental impacts of maritime transport: air pollution, marine pollution, waste dumping, release of toxins by paint, migration of aquatic organisms, shipwrecks, and or cargo losses, noise and collision with marine mammals. We spoke about the issue of the atmosphere pollution. That is one of the main areas, the first areas in which the IMO had a proactive posture. Yesterday we saw that this regulation was reactive. It happened after the accident, but this part of atmosphere pollution is one of the first areas in which the IMO had a more proactive posture. So it's not the answer to an accident or a problem. It doesn't exist in most of the planet a great pressure in terms of public opinion regarding atmospheric pollution caused by the ships, but the IMO decided, or the people part of it, decided to participate, to anticipate the problems that might occur. There's a greater scrutiny that the maritime transport starts having in the public opinion to start and regulating atmospheric emissions of the ship. These atmospheric emissions are not very different compared with other kinds of combustion in other transportation means, except some cases. In terms of route transport, a few years ago, there was a decrease in the tier in sulfur. There was the help of heavy fuel and other resources, and but the sulfur index is still very, very high. In terms of atmospheric pollution, it's one of the first areas in which the European Union is anticipating what the IMO regulation is. It already establishes some objectives that are a bit more demanding and a bit more rigorous than the objectives of the IMO. And they started establishing new aims, new objectives, even before having a guarantee that the technology might be able to answer to these objectives that are being proposed. The marine pollution, what the marine activity can leave in the water, has to do with dumping, with accidental dumping, and with intentional dumping. It is still possible to do hydrocarbon dumping into the sea. It is just made in a more controlled way, or more homeopathic, I would say. In terms of homeopathy, as you say, there's a dilution degree that is very elevated in the medication. And the first annex of MARPOL still allows an homeopathic dumping. Another of the impacts of this waste dumping, and when I speak of waste, of course, I'm speaking of domestic waste, what we usually call domestic waste that have the same equivalence in the ships. Release of toxins by paint, especially the paint that is in contact with the water, migration of aquatic organisms through the transport in ballasters, shipwrecks, cargo losses, and yesterday we saw this new approach to the problem, that is the noise and the collision with marine mammals. In terms of regulation instruments that we're going to approach here besides MARPOL, the Anti-Fueling Convention, the Ballaster Waters Management Convention, the Recycling of Ships, the Convention for the Preparation and Answer in Situations of Pollution, the Intervention Convention, and the London Convention for the limitation and control of dumping of several products in the ocean. I'd like to speak first about MARPOL, but also about the London Convention. And then there's another development, that is the London Protocol. The London Convention is a convention that was rectified by Portugal. The London Protocol wasn't rectified by Portugal. In its initial phase, the convention said that we could deposit in the ocean some materials except those who were in a table. What the Protocol of London brought was an inversion of the way this regulation was seen. Instead of being able to deposit everything except what was in this table, we could only deposit what was there. That was a very limited number of products that can still be deposited in the ocean, one of them being what is, of course, unavoidable, and that is deposited every day, and that are the trained products, and also some other products, as we'll see a bit later. This London Convention shows and is currently a mirror and gives a very faithful image of this ability of sustainability in maritime transport. In 1969, it started establishing a list of what couldn't be dumped in the ocean, and then it knew this inversion, bringing a very finite list of things that could be dumped into the ocean, and still within a perspective of limitation of harmful aspects that this deposition of materials in the ocean could have. This convention has an adaptation that allows it, instead of introducing materials that are harmful and that can somehow be a negative aspect of maritime transport sustainability, it today allows to introduce materials that contribute to a greater sustainability in maritime transport. The main and only being regulated is currently coal, CO2. And after these changes, it's possible to introduce CO2 in the subsoil, trying in a way to compensate this balance that we are breaking with the use of fossil fuel. Depositing carbon in the subsoil is a process that nature itself always used, and through this process that we are now driving our vehicles, and we send our merchandise through maritime transport or route traffic. All this deposit made after millions of years the formation of fossil fuels.
And a second department in this London Convention and Protocol, and also the new amendments, it's the usage of fertilizers. Marine fertilizer has a role, especially iron fertilizer we use in our backyards is, for example, compost. Please make it simple to make flowers and the plants grow, right? That's the goal. Fertilizing the oceans is exactly the same thing. Make the phytoplankton grow. What is the role that phytoplankton has in the global balance? As any other plant, what are the things that we have in our availability in terms of capturing carbon? Either we buy parcels of forest, or this is a finite resource, or to increase the rate of absorption of phytoplankton. The idea is to establish a balance for absorption of carbon and then placement on the subsoil, instead of being an artificial process of just sticking carbon in the subsoil artificially. We use a natural process, right? This is the most beautiful part of the idea. The less beautiful one, not to create an excessive enthusiasm, is that part of the scientific community is very critic regarding the fertilization of oceans. The saline effects are not well known, but this will probably be the area, I think. I'm just a sailor. The excellence area of environmental engineering, because we are manipulating the environment. There is not a monitoring of processes, but there is an intervention bringing biosphere to have a type of predefined answer. Hello, Elliot. Okay, so it's now time to give you a challenge. What startup can we develop like this development of the London Convention and Protocol and these most more recent amendments? If you wanted to develop a startup, what could we do? Create a company. What business? How can I interact with maritime transport through these regulatory instruments? What business? Well, it means that I need to have something to sell. What can I sell here? I have a client. Maritime transport can be the client of a startup connected to a business arising from this regulatory sector. Well, this is just regarding these recent amendments to the London Convention of '69 and the protocol. These amendments had allowed storage carbon dioxide in the maritime subsoil and the fertilization on a level of experience in oceans to increase phytoplankton and the ability to absorb CO2. We are just addressing this convention. What type of opportunities does this present? And in which way can a startup address and establish a relationship chain with maritime transport? How can this benefit maritime transport? How can this benefit the startup itself? What product can I sell through fertilization of oceans? Maybe you could sell a product to ship owners, making the ecological footprint disappear. This could be made with fertilization or with the capacity of phytoplankton to absorb. And is that a business? Well, if we have a client for it. At the end of the day, you have an ecological footprint. It would be a certification. It would be a certification of the structure itself of the ship or of the company that would ensure an ecological footprint of no risk. Yes, I agree. What's the importance of that for the sustainability of maritime transport? Well, it would, regarding the market, it would decrease the risk and it could be competitive in terms of cargo transport. A ship that, due to its emissions, cannot go to a SECA or ECA, having this insurance that this startup would bring, that the ecological footprint due to the hours of functioning would be compensated for the planet, and all these different perspectives could be benevolent and let the ship go in those areas, for example. That's one idea to be explored, I believe. Thank you. These are not news. The fact we have a company in Portugal, Tecnoveritas, that won recently an international award for innovation concerning a different system to take advantage of combustion gas that allows ships who, even with poorer fuels, can uh, enter areas that are restricted. There are solutions, and this is an example of a Portuguese company with Portuguese technicians that is working on this subject and then has a consultancy service and technical assistance for the management of effective systems that optimize combustion and emission reduction. This is an example of what is already being made in Portugal. It's good to know, and it's good that those who are outside of Portugal are getting this idea and this news, taking good note of this award that you just mentioned. Anyone else wants to intervene? Well, I think that we have two or three different notions that are not completely defined. I don't know if they are clear for everyone. Of ECAs and SECAs. ECA to start our emission controlled areas, areas where the air emissions that the ships can have are controlled, are subject to values. SECA also has the control, only has the control of sulfur in mind. This is a notion that is disappearing because control is being addressed, and there are ships that regarding emissions are controlled also. So it will be replaced by those ECAs. Where do we have those ECAs? I would leave that part for the development of Marpol. I will tell you about Marpol exclusively in Annex 1. And the sixth annex is the most recent one where the IMO is trying to regulate some ability of proactivity and just to address the theme of the opportunity of business on a startup in this area, either the storage of CO2 and the fertilization of oceans only allow us to work on CO2. And about the emissions of CO2, that's the area that has less regulation in terms of emission of maritime transport. There are already in existence projects of regulations. There are some guiding principles, but that is the less regulated area, and it has to do with energy efficiency. The capture of carbon can be a decisive factor. This was a more interesting business than it is now. The gross tonnage of carbon has been decreasing significantly, and so this is today, as we saw yesterday, the sustainability is always a long-term idea. Let's talk about Marpol a little bit. It has 6 annexes. Each one of them regards a very specific risk. He spoke about hydrocarbons. The number of the annexes has a reason, chronological reason. This has chronological reasons. The pollution by hydrocarbons was the first concern regarding regulation, and it happened after the incident of Torrey Canyon, and it comes to establish rules regarding construction. The great risks of spillage have to do with the construction of the ship. As we saw, Torrey Canyon had structural problems that were quite serious, and the transformation of Jamboise that brought some fragilities in the structure. Other pollution risks by hydrocarbons was a result of tank washing. So we are now trying to understand how to have tanks that work exclusively for the ballast. And we are starting also to speak about the monitoring, control, and verification, not in this order exactly, but the ships need to be subject to in the operation with liquid or products with this degree of danger for the environment, to which its operations are possible to be followed. In the beginning, it brought some difficulties. It increased the bureaucratic tasks aboard. Today it is documented any lubricants or fuels or dangerous cargoes needed to be documented, and it was with a tendency to be inspected also. The Annex 2 has to do with noxious liquid substance carried in bulk, others that not hydrocarbon. Third one has to do with substances carried by sea in package form, and the package needs not to be commercial. It can be industrial also, or exclusively destined to transportation. The fourth, for pollution by sanitary sewers, and only in the 80s, and the control of the port, we are starting to have a very active role in this area in terms of regulation. The fifth annex, production by waste, solid waste. And the sixth, more proactive one, for air pollution by ships. And in the air pollution, we have all these things here. The odds, charged substances that have a character that uh, makes the ozone layer poorer. There are also some laws on European level to treat these substances in earth facilities. As you know, today, to handle on a facility, on an air-conditioned facility, an older one, you need to see a certain number of rules. We have regulations that we cannot recharge with the same gas that existed on those devices. There are specific type of gas, and there are regulations to withdraw those gases when it goes to recycling. Halum extinguishers also disappeared, except aviation, because it has an extension of the deadline to extinguish the halum extinguishers for 2050, I believe. How long are a process of fire extinguishers that are quite effective and with an advantage for the aviation that they take very little space on board. They are already gone for a few years now. At all the facilities that exist aboard with nitrogen applied substances need to be controlled exactly the same way that they are in the facilities that have stored gas in the land. The sulfur oxide, first substance being controlled on the European Union regarding those emission control areas. There were some studies recently on the impact of the emission of ships on the concentration of some products, sometimes harmful, in the air on coastal cities. And the contribution Regarding CO2, as we said before, it's 3 or 4% of the CO2 produced on the worldwide level. In some other compounds, the percentage is clearly higher. Regarding particles, we have three indexes of particles regarding the dimension in microns, being that those who are more green and blue, there are the smaller ones, are the ones that are already able to go inside the respiratory tract. And in some cases, we have some areas where shipping has a participation of already 20% in these emissions. These are data that there is very recent. Regarding uh, nitrogen and sulfur oxides, this area of the Baltic and the Northern Sea, it's where these concentrations are higher. The contribution of ship emission is higher. There are different reasons for the density of traffic, to the ecosystem itself that brings the possibility of higher emissions and concentration. There are increases of almost 50%. We started measuring this in '07. These areas are areas where there is emission control, as you know, since the year began in the Baltic and in the Northern Sea, there is this green limitation for the percentage of sulfur oxide, exactly the same limit that we have inside ports, and that it will be enforced also globally starting in 2020. 2020 or 2025, this limit of 0.5% that will be enforced, this doubt it's only for the IMO. The scope of the European Union, it starts in 2020 and that's it. Anyway, there was a need of making a huge adaptation, technological adaptation of the ships to navigate in areas with emission control. There were three technical solutions presented. If Elio, if he's able to, maybe he can bring the fourth one that he mentioned, uh, the one that's more simple. It's to uh, use marine gas oil instead of aviation fuel. More complex, demands some technological investment, is to place an emission filter to to perform some cleaning of the emissions before they go into the atmosphere. The third, that has been the last used one, it's the usage of fuel that can be in accordance with this regulation, which is natural gas. Point of debate. If I were to have a ship to work in the Baltic with the decrease that we have seen in the BDI, and with its limitations, and which way can I make my business sustainable? Okay, I'll give you an idea, and then I will ask you to give me some alternate ones, okay? By, um, you know, stopping the business. Other alternatives. Does it or does it not have economical implications in the business in the sustainability part is changing regulation? There is a difference in the price between both types of fuel. The scrubbers have an installation cost. The natural gas has two costs associated: tanking and engines. The use of natural gas on board, it's not new. This has been done in the ships that carry natural gas, used as fuel also. They have no problems in tanking. Here we do. I'm working with dry bulk. I have businesses in the Baltic area. All of a sudden, I'm facing this aspect of regulation. This is not to have a beautiful image in a flyer that I print of my company saying that I have ecological footprint that's quite reduced. This is mandatory. This is face of the problem, thinking that not all of the scopes of the business, the environmental one, uh, let's the social and economical one aside, how can I try to conciliate both of them when I'm facing a change on regulation that has an impact on the economical sustainability of the business itself? What do I do? Do I change to gas oil or do I put scrubbers? Do I change to natural gas? Well, there are a lot of factors to bear in mind. Access to financing of the fleet in the area. Let's study the three hypotheses, trying to find some advantages and some disadvantages of the three hypotheses. The alternate usage of gas oil and heavy fuel advantages: quicker, well, it is my opinion that within a debate, this is a strategic debate and it's related clearly with the time and with the real time that the ship will stay in that area. This meaning that we were speaking about different business models in shipping. We have several freight models. If we're talking about a ship that is working by trip, to me, if it's a sole trip to those areas, it's easier for us to spend a little bit more and purchase fuel that is in accordance and allows the entrance of the ship in operation in that area. From the time that we have a freight agreement, an FFA, in time, if it's in bareboat, the problem goes to those who are clearly, I'm speaking from the point of view of the ship owner. Yeah, but that's the part that I wanted you to define. In the perspective of the ship owner or of the charter. Yes, I'm the ship owner, yes. Well, on the point of view of the ship owner, it depends on the freight agreement, the FFA that the charter has, and of the time of operation in that specific area. In a perspective of migration to other technologies and what our colleague was saying and debating, to me, it's a perspective of profitability of the useful time of the ship to know if the changing that I am imposing to the ship, if the payback of that implementation comes within the period that I have in mind in terms of the life of the ship, if the cost of the transformation pays back the investment, or I will have to freight another ship that already has this technology, and I put my ship in other areas. Hence, the life of the ship doesn't matter anymore. Anyone else wants to speak about the business? Please don't forget that the consequences that I bring to use a more expensive fuel, the value of the freight, and the market index will not have any changes. I will have exactly the same, whatever the charter or whatever the solution that I'm presenting. What has been studied, the payback for natural gas and for scrubber, it's more or less 8 years navigating 50% of the time of an acre. This is in front of us. Here in Europe, it's a 0.5%, and that's it. How do I make my business sustainable? I'm within the perspective of the ship owner, and the charter is not a transnational entity filled with executives with headquarters in Zurich or London. The charter on the solid bulk transport is someone like us that bought a ship. We all of us know a cousin or an uncle that bought a truck, and so we buy a ship. Let's bring some variables into this equation. Then we will get back to the initial diagram to make it simple, but let's make it harder even more, okay? Let's start. We'll start on the short term facing the emission of nitrogen oxide. The only fuel that is able to be in accordance with the NOx emissions, it's gas, right? You brought a new ship, okay. If you buy a new ship, It needs to be in accordance with various legislation limiting the emissions in NOx. The problem with buying a new ship regarding those financial flows that we've seen before brings some imbalance in that area, right? How can we be sure of natural gas here? With a charter, what's the main concern that this frame can bring to us? Everything that's in this chart here, what number, what expression would bring some concern as ship owners? Yeah, I have an opinion. Give me an adjective. Yesterday we spoke about this, that it's extremely harmful for business. Yesterday we saw this from the point of view of trust, lack of trust, uncertainty. What can you see here that brings uncertainty? It's one of the greater complaints in industry. It's this uncertainty regarding regulation. More than the demands of the regulation itself, it's the uncertainty regarding the regulation itself. What will be regulated? The or it's the basis, that uncertainty. There was a reason for the EU to eliminate that uncertainty. With that data, we will return to our company only has a ship for transport in bulk. It has cereal on it. We have transported cereal from the Northern Europe part to Leixões, to Aveiro. What do I do with the ship? Bankruptcy file. What do we have here that's future proof? From these three hypotheses, which one is future proof? Natural gas, of course. Okay, and then I buy a ship with natural gas. I don't know if there is something that's future proof. The only thing that we are sure of, the only certainty that we can have is that changes will occur. From 2025, there is a new regulatory framework that brings some emissions, not only NOx, SOx, and that natural gas, that it's not a solution. Even in this type of businesses that we have, in which building a ship or adapting a ship has cost 25 years, It's very difficult to have a future that's bulletproof. It's not possible, I think. There are things that, according with things that we got to know now and with the report that we have, we are able to say that it will be a good solution. If that solution in the future, after 2025 or 2030, what will happen next? Will we have the control also of the CO2 emissions, for example? So I believe that specifically a bulletproof future, it might be an expression, I would say, with an expectation that I believe it's not possible to have nowadays, but that's my opinion. More opinion? Of course, we need to decide with the info that we will have today, not the one that we will have tomorrow. And to give you some prediction, like a famous football player, the information that we have today is this one. The one that we have available is this one. The investments are this one. They are deductible in this deadline, okay? This is what we are working with. That's the only info that we have at the time to make decisions is now. Those payback 8 years are just for the initial investment, right? Then you have the difference between the fuel costs, natural gas or heavy fuel. Regarding the scrubber, the investment is on the technical part and the maintenance of the waste itself that it's retained here. Price of natural gas has been decreasing exactly like gas, oil, and heavy fuel. It is now in the descending direction. The main problem is if we are to analyze retrofitting, the application of new technology to a used ship always has the advantage of being able to be reverted. That doesn't seem like an advantage to me. Well, and the disadvantage of tanking, for example, well, it takes space. Not necessarily cargo, but it takes space, right? We are addressing a bulk ship, solid bulk, takes space. It can take up space if we can reduce the cargo capacity. If it's on a tank ship, it can take up space without reducing cargo capacity. Some problems in terms of stability, but can take up space without reducing cargo capacity. But once again, stability problems. But that's solvable. Are there LNG ships working with solid bulk? I have seen it in ferries, for example, but not in bulk. Yes, ferries has been a very fertile ground in terms of research, exactly because they don't need greater autonomy. We have ferries working only in batteries from one side to the other. On the other side, it changes batteries or recharges. Ferries is, in fact, and truthfully, the area in which we are using more for research, but we are addressing commercial exploration. The business needs to be made. The movement of cargo still are in force. We need to do something. Just to give you some data, I was checking here about the solution that Tecnoveritas is placing in the market today, and I'm at their webpage, and what they're saying is that technology that they are able to install, what they are able to install in their ships allows two different things. On one hand, they are able to reduce the particle and nitric oxide and NOx and SOx emissions, but they are also stating that they can ensure a reduction around 5% of fuel consumption in regular usage of the ship. So 5% on a ship with 4.3 megawatts in power means 220 something euros a year of savings. So what they want to state is that we are not only able to solve the emission problem, your ships can go and work at the same way using not so expensive fuels, but we are also able to gain in the efficiency of the thrust system itself. This is a solution that seems to me it's quite balanced to examples in which the ship or the ship owner that does not predict to prolong the usage of the ship that 2020 or 2025, or that has an operation that it's not 100%, about 50% in ECA areas, or not much more than this. I think it can depend a lot if the ship has regular trips in ECA areas from the Mediterranean and the Northern Europe, in which ships are within that circuit inside ECA areas, or ships that have great distances outside ECA areas, for example. There, I think the cost might be a little different of using a regular fuel.
Everything that I brought here is a payback from 8 years ago regarding natural gas in use of 50% for an ECA. The Mediterranean is almost there. If it is, does it change your options, or do you maintain them? Or do you still want to use marine fuel? If you do, what is going to increase here? The use by ECA. It changes completely the panorama of the business. Anyone else wants to intervene? Just one question. In terms of autonomy, let's imagine a ship that makes a journey between South America and Leyland. To work with natural gas in terms of autonomy, what does it mean? Is the dimension of the tanks reliable to make this journey? The solution of natural gas brings, in terms of technology, some reduction in ship autonomy. By the studies that we've been making, not really. Would it be necessary to eventually refill the tank at sea? I've read a case in New Zealand or Australia, I don't remember, of the biggest ship that fills up in LNG in the high sea. It's one of the possibilities. All the dimensions of the ships, as you will understand, these LNG tanks are quite big. It's usually not stored in proportion, but just by not by pressure, but by cooling. Otherwise, we could store a greater quantity in a smaller space. It's not the case here. It's one of the possible approaches of the problem. It's to have more refill points, and it's an approach that that is made in terms of vehicles, electrical vehicles. We can have several options investing in terms of research and development in increasing the autonomy of what we have. In the case of natural gas ships, the weight that is being transported doesn't really change. What changes is the volume that is occupied. The volume, of course, that has a translation in areas, it's a challenge. It's a great approach. The second point would be to have supply stations that are more regular, more frequent during these journeys. It seems to be an interesting technology to me. For short and long distance journeys, it's a technology that is clearly needing some work in terms of technical options and in terms of logistic options for long distance transport. But what we're saying here is regarding short distance transport. It can be a solution for bulk transshipment, just as a container transshipment is made. Many solutions can be adopted here. It all depends on the way that it affects the bulk transport. Yes, in closed circuits and in open circuits. It depends on the bulk. Here, what worries me the most is the percentage in the ports. Any questions? Here, in red, just to move on a little bit because we are running a little late, we have the current areas where the emissions are controlled, and in orange we have those that will possibly make this future emission control. The area of Mexico, Mediterranean, Japan, all the areas in orange. I'd like to move on now to the anti-foulings. I don't know if you still have questions regarding atmospheric emissions. Anti-fouling, I don't know if all of you are familiar with anti-fouling paints that are put in recreation ships and small shipments and in big ships as well to prevent the development of microorganisms in the part of the boat that is underwater. What is the problem with these microorganisms? The increase of the frictional resistance. It significantly increases with the adherence of these microorganisms. We're speaking about algae, mollusks. The process that is being used currently to prevent this adherence is the use of paint with biocidal substances. It is what is used in our gardens as a herbicide. It has the same effect. Instead of being applied, pulverized in our garden, it's applied in a permanent way through the paint and through the renovation of the paint. The control Convention for Anti-Foulings with Harmful Effects in the Environment is from 2001 and came into force in 2008. Portugal is not part of this convention. However, there is a European regulation that has the same effect. We are not part of this convention, but the European Union is a member of it, and we are inserted in it, so it has the same effect. The European Union has been accompanying the evolution of the way how the international community has treated this anti-fouling convention through the 782/2003 regulation that came after the adoption of the convention. And then we have another regulation, the 536/2008, that is subsequent to the coming into force of the convention. And it phases out the use of biocides. It establishes rules for removal of paint already applied. The paint that is already applied can stop having this negative effect by two solutions. First of all, removing the paint and changing it for a paint that has a different effect, and to seal the paint that is already on board, to put another paint on top of it until removing the two layers to stop it from having this effect. The painting of the hull has to be certified. The only problem of not being part of this convention for us, although we are forced in terms of fleet with the flag of our country to apply to these rules, we only raise the problem of the inspections with our port state control. We can fiscalize this rule in Portuguese flag ships, but in terms of international legislation and international maritime right, we raise some difficulties in doing this inspection in ships with other flags in our ports, just because we are not part of this convention. This is the only limitation that it has. The Anti-Fouling Convention is now in force, and we're going to speak about the Convention on Control and Management of Ships' Ballast Water and Sediments that is not yet in force. Although it has been approved in 2004, if I'm not mistaken, it still hasn't gathered the number of adhesions that is necessary for it to come into force. In terms of countries, there are enough adhesions, but it needs more tonnage adhesions, 2% of it. One of the big countries with registered fleets just has to do this adhesion for this convention to come into force. There also isn't still a regulation in European terms with and compulsory characters for the state members. There's some work done in the European Union. There are some state members that are part of the convention and that already delivered their rectification instrument. They also have a series of dispositions in their legal system to follow the dispositions of the convention. But in Portugal, at least in terms of the European Union, there isn't a legislation that makes it compulsory for the state members to follow the regulations of the convention. What can be the environmental impacts that this convention wants to decrease? That is the transport of organisms from one ecosystem to another, and especially in case of most vulnerable ecosystems. We have here three cases that are those who are most presented internationally to show this impact of the movement of ballast waters from one ecosystem to the other. One of them is curious. It's the case of jellyfish. approximately 6 years ago, I've spent some holidays in the Black Sea, and it was filled with jellyfish. It isn't supposed to be there. It's not part of the ecosystem of the sea. It's an organism of tropical waters, and so they were transported. And I think that they went from the Black Sea to other seas, and then followed a network of canals until the Caspian Sea. What's the problem of the jellyfish here? It could be nice to have some jellyfish around. It's of course it's a predator organism, and so the fish captures have been decreasing in the Black Sea, so it has a very harmful effect on the environment. The most fun part of the theme is that meanwhile, by the same way, another species of jellyfish has been arriving to the Black Sea and has been eating the first species that got there. So in an unintentional way and in an accidental way, the balance has been restored. These mussels and the crabs that you see here, especially the crab, it has been involuntarily migrating in the hull of and ballast waters of the ship from Europe to the American continent, especially into Great Lakes. As you know, it's an organism, a living being that is quite voracious, and that has a very significant effect on an ecosystem. It can create great imbalances very quickly. This is the scientific proof that is presented by the International Maritime Organization. There are opinions that say that this transportation of microorganisms was always made in the story of our planet, not in this accidental way through ballast waters, but through currents. Anyway, the international community, through the IMO, decided to adopt this convention for the control and management of ship's ballast water and sediments. And it proposed to do it in two different ways. Of course, this problem appears in trans-sea traffic, and so they wanted to do this control in two ways. First of all, there had to be a process of elimination of these organisms aboard the ships during the transport period. The installations or the tanks, the ballast tanks, should undergo some chemical process or other to eliminate these microorganisms. The second solution would be during the journey to make a renovation of the ballast waters and replace the ballast water with the microorganism with seawater that would be kept a part of the hull. So a regeneration process of the water from the water of another continent being renovated by seawater during the journey, so as not to have microorganisms from the source country while reaching the target country. Implementation problems of this convention. Generally, they're always ahead of this initiative, but the Baltic countries have had some problems with this convention because they do not have this possibility regarding the 200 miles. Their journeys are short duration, their ports in the coast are very close, from each other, and so there is no way to making this renovation. And another problem is doing the ballast discharge not into the water, but into an installation on Earth that would treat the water. Our European partners from Sweden that usually are way ahead in adopting these conventions and who have these convention in intern legislation have mentioned implementation difficulties because they say these installations are way too big. We're talking about tank capacities that are way too great to receive all the ballast water from the ships. What is seen in this convention are measures for ships that already exist and also some measures for ships who are still being built. These two standards, the D1 and the D2, the D1 is the idea of exchanging ballast water with seawater, and the D2 has to do with treating the ballast water so has to be free of microorganisms that might interact with the target environment. These are the two ways to treat the ballast water, the standard D1 and D2. And the application would depend on the year of construction of the ship. So starting in 2012, the new ships with less the new ships need to have the D2 standard, or should if the convention came into force. And the ships that are subject to retrofitting, ships that are already exist but have to be adapted to fit this convention, can still use the D1 or D2 standard until 2013, except those who were built before 2009 with a ballast water capacity between 1,500 and 1,500, and who could use technology to sanitize the bottled waters until 2016. This is the state of art in terms of convention for the ballast water. Once again, it is not into force yet. Some countries have already adopted it and already have it in their legal system, and some others are experiencing some implementation difficulties. Except another country that is generally ahead in this aspect as well is the United States. And the United States have, since 2012, specific norms for ballast waters, and especially for ships that enter the Great Lakes that have to present all these systems work with quality control systems. And so everything we do with the ballast has to be supported documentally. There has to be diaries, fuel diaries, for example, and where ships will start having also a ballast diary to be able to say what quantity came in which port, if regeneration was made during the journey, when this regeneration started, when it ended, at what point in the ocean this regeneration into seawater was made, and to gather all these demands of legislation to what was said yesterday in terms of sophistication of monitoring process and communication process. It's getting easy to trace these processes. The fiscality authorities, the regulatory authorities are starting to trace these processes. They start to be documented, We know that many of the conventions and the demands of these conventions are often uh, changed. We find ways to go around all these conventions, but with the sophistication of the process of real-time communication, these measures start to be quite efficient. 20 years ago, we didn't know that the position of the ships was monitored in real time, and nowadays, in terms of international legislation, it's being done. First, it was only for maritime transport by the coast, and now it also applies to oceans, long-range identification traffic, and all of this is getting less an idea of sustainable measures, but they're being easier and easier to implement and to verify. Our EMSA, as you know, it's an organization that is very interested in environment and maritime transport, and that has a very reactive attitude. It appeared after the accident at Erika. It has on its website this small graphic here that relates the impact that it has on the oil pollution, that the hydrocarbon pollution has on the environment. The immediate effects are not visible right away, but the effects will be much more important on the long term than the effects caused by the hydrocarbon, because hydrocarbon is still something that is quite physical, either solid or liquid, but there are very few pollutants that can still mix with the water. Some of them still don't use technology at an acceptable scale to make all the necessary changes, but it's always viable to do this removal. It's always possible to have correctional measures. In the case of microorganisms invasion, there are still no measures to change it and to correct it, except the jellyfish predator. As we mentioned before, there are no other measures to correct it. That's why the long-term effects are much more important than the effects of pollution by hydrocarbon. Yesterday, and to finish the first part of my presentation, someone mentioned the problem of recycling. How was ship recycling done in the same country or where it was built, or in a different country? We saw that China, who's one of the greatest construction countries, is also one of the biggest shipbreaking countries. There's here a convention for the sound recycling and environmental recycling of ships. This convention is not into force as well, and Portugal is not part of it either. There is, however, legislation in European terms so as to start and to suggest some acceptable practices in terms of ship recycling. Recycling is a term that, as here mollusk character. That is something that can be transformed. It's not an idea of recycling that we are used to in our everyday life. Life. What the European Commission is trying to do is to try to abandon this term of recycling and to change it with displacement because it has quite big implications in terms of the ships. If we consider it recycling, what are we recycling? In generic terms, not in specific terms. Waste. What we recycle is waste. Here we are talking about a transformation of the ship into recycling. We have here an approach to try and satisfy both concepts, not ship recycling, but the transformation of ships for recycling. It's very different in terms of juridic implications. The main concern here of the convention are the aspects of security and health of the people who work in this activity. In the big countries where the recycling is made or the transformation for recycling is made is in Asia and especially India. The initial recycling process has 4 variables that are quite important because the first one is the principal target, the main target of this convention, that is the beaching. Beaching is basically taking a ship and leaving it on the beach. It's usually done in countries that have competitive advantages for beaching, that is countries that have higher tides, which allows people to just leave the ship on the beach, and then the tides just grow, and the ship just stays indefinitely on the sand. Of course, there's a series of operations that have to be done until reaching the next period of high tides. The second technique is the slipway. Beaching is mostly done in Asia, in India, Cambodia, Bangladesh. We just leave the ships on the sand. Slipway is a similar technique, but we just do it in countries that don't have such a high tide, for example, in the Mediterranean. It is mostly used in Turkey. We'll also ground the ship, but we usually don't leave him on a sand beach, but on a beach that has quite a surface. The issues of the beaching are quite larger in environmental ways. In slipway, we can channel the environmental issues in terms of recycling and shipwreck. The initial recycling process can also be done in docks that aren't being used commercially anymore, as we do in China. So we leave the ships there and we can move on to the recycling. And the most expensive technique, the dry dock, can be done with an absolute control on the environmental impact that the operation may have, because it is in a contained space. Nothing that can be spilled or dumped during the scrapping process is going to have an impact in the environment. The impact that this might have is, of course, maritime pollution. In the slipway, we are able to make a greater spill control. Beaching is a fertile terrain for maritime pollution. In in the case of birth, what can happen is local contamination, but it is also possible to contain it. The dry dock is safe, the most safe technique, but it also has a high cost. A high cost. Um, Recycling and shipbreaking on dry dock is done mainly in Liverpool here in Europe. The shipbreaking centers and recycling centers also exist in the Netherlands, and they also use the dry dock technique. In the United States, all those who exist also follow the dry dock paradigm. And so we're talking about shipyards that exist in evolved countries, and these facilities are subject to licensing and are regulated. They handle a series of products for which a licensing is mandatory. This is the aspect that has to do with beaching shipyards. If you notice here, we have areas where people live right next to the shipyard. It's not very easy to see, but most of the workers have to go around the shipyard without any protection, without any equipment. If you want to do some more detailed research, you will find some bags on the beach with waste, and we see people just with asbestos, and we see people just walking next to them. So these are ships that we use for years that brought goods here to Europe for us to consume. And at the end of their life, that's what happens to them. The life expectancy of the people working here next to the asbestos bags is not very high, as you can imagine. The United Nations have sponsored a visit from a delegation in 2010 to this shipyard. I mentioned it yesterday, and the only country that didn't get this visit was Pakistan due to some political tensions existing by then, so it wasn't considered safe for the mission to go to Pakistan. And there are some recommendations here of the United Nations envoy to the Indian government in this particular case. He didn't ask much, but he wanted that in these places the labor legislation in the country should be adapted. He wanted that the children living nearby, the children of the people working in these shipyards, could have a school, first of all, the possibility of having some education. What we want with the convention, first ensure that this operation is not a danger for people working there, for people that are part of this shipbreaking, that separate it, break it, that have to move the steel that is the greatest part of this business. There are some notions that are already applied in the automobile industry. Each car has to have 80-90% of recycled components. So there's a great percentage of components that can be reused. And if we see the shipyards, the shipbreaking sites that exist in Europe, all of them are associated to a network, to a small business that sells used equipment that belong to the ships, but that can still be used, that still work. The convention starts to make it mandatory for the construction of the ships to make it easier to break them later, to dismantle them later. They already use modular construction processes, so the ship is no longer completely built in the shipyard. It is built in a modular way and is then put together using a technique that is quite similar to the technique of Lego. So it's a building technique that allows a greater rapidity. It allows the shipyards to focus on putting the pieces together and not on support activities such as cutting steel or other soldering, welding activities. The convention also makes it mandatory for the ships to have an inventory of the dangerous materials that they have on board. So when they are being prepared for shipbreaking, they have to bring this inventory with them. It has to be documented, and then the shipyard that will take care of the dismantlement has to take care of the reduction of these substances. There's a mandatory certification for these recycling facilities, and this regulation 1013/2006, we don't exactly know where it fits in the convention. The ratification requires some criteria that are 15. They have to do 40% of gross tonnage, and the states have to be working in the ship recycling business, and 3% of this tonnage has to be recycled in the last 10 years. With the relation that it is preparing, the European Union is going to make a list of the shipyards that, in fact, are in accordance with these safety norms, so that the ships of the European Union can be dismantled there. This nice part of the regulation, the part that is less interesting is that the list will only be ready in 2016. So these images are still repeating themselves every day. So we're now going to take a little break.